Hey guys, coming at you a little bit different this week. I'm trying a new little method of recording just to get my face in there a little bit and say hi to y'all. So just remember as we go through these lessons, I want you to try your hardest. Today's lesson is going to mirror the Desmos you're going to work on, but it's not going to be identical. And then I just want to make sure you're taking advantage of emailing me if you ever need anything or hitting up those office hours. It looks like they're going to be every Wednesday pretty much, unless I pump out something otherwise, 3:30 to 4:30. But emails running all the time. I hope you're all doing well, and I hope you're all being safe and happy. And let's get to the math. So today we're looking at tables and graphs. And big picture, we've talked about this before. We have multiple representations of functions. So right here, you can probably see I have one representation of a function, and that is an equation. And it looks like we're gearing up to have another representation of a function, which is a graph. So the one way we get from an equation to a graph is using a table or a t-chart, you might see it called, or you might hear me call it an XY table. So for the XY table, what I like to use is, you might recall from our domain and range discussion, we have domain X and a range Y. And I personally really like domain -2, -1, 0, 1, and 2. So if I'm given a choice, that's the domain I try to use. And the reason for this is I have negatives, positives, I have a 0, and I have numbers that are easy to use. They're relatively small numbers. So here's how I use these. Let me just move my iPad for me. Sorry about the noise. How I use these is I can take my X values from my t-chart, substitute them into the X values, the X spot of my equation, and I can pump out Y values. So let me show you what that means. And you wouldn't have to do this every time. That means I can figure out what Y equals because it's 2 times whatever X is. So when X is -2, Y has to equal -4 because 2 times -2 is -4. When X is -1, Y has to equal 2 times X, so Y would have to equal -2. When X is 0, Y needs to equal 2 times 0, so Y is 0. When X is 1, Y has to equal 2 times 1, Y is 2. And when X is 2, Y has to equal 2 times 2, or 4. And what each one of these gives me is an ordered pair on my graph. And I can graph ordered pairs. So -2, -4 would be right here. -1, -2 would be right here. 0, 0 would be right there. 1, 2, and 2, 4. And if you think back to the last lesson we did, this is a proportional relationship. It goes to the origin, and it is a straight line both. So there's the first one. And remember, rewind, okay? Rewind, because there's a good chance this is quick, and I know it's quick. I want to give you enough time to work on the Desmos too, but feel free to pause, rewind. This is like your notes, right? You can look at this as you do Desmos. So as I'm looking at this function, notice I have a different coefficient this time. My coefficient this time is 1/4. And so you could keep rocking that -2, -1, 0, 1, 2. But that's going to pump out fractions. So since I get to choose the domain and range, in this case, I would actually, myself, like to choose a different domain. I know that the numbers like -8, -4, 0, 4, and 8 would pump out pretty nice numbers because 1/4 of 8 is 2 and 1/4 of 4 is 1. So let me show you what I mean. When I start substituting in my X values, it would look like this. So let me just write down all these X value substitutions. I apologize for any whining you hear in the background. My wife is putting the kids to bed, depending on the night. All right, so here's all my X values substituted into my function. Remember, this function works for all of them. And so 1/4 of -8 is -2. 1/4 of -4 is -1. 1/4 of 0 is 0. 1/4 of 4 is 1. And 1/4 of 8 is 2. So you might notice like negative 1, 2, 3, 4, 5, 6, 7, 8. That extends off my graph. We wouldn't have to have that, but there it is. Negative 4, 1, 2, 3, 4, negative 1, 0, 0. Ooh, through the origin. So we're proportional again. 4, 1, and 5, 6, 7, 8. Oh, I fit it all on. It might not always all fit on, but you still remember all these are reference points. These aren't like necessarily, these are all answers to this function up here. They're all answers to this, but there's infinite answers. The whole line, anything on that line forever is the answer, and that's why we have to put that graph of a line. These are just domains and ranges that we're like choosing to try out to get our graph. But our graph that extends forever in both directions, that is all the answers. All right, you might notice this one's different, right? We got a little something, something extra right here. And that is going to tell us that this is not proportional. This is not going to go through the origin. As you set up an XY table, the number I'm multiplying by isn't a fraction or decimal, so I'm going to stay with my domain negative 2, negative 1, 0, 1, 2. It's just pretty nice to work with. And this time, I'm going to choose not to write out substituted in every time, okay? So all my x values, remember, get substituted into there. So when I do 2 times negative 2, I get negative 4. Negative 4 minus 2 is negative 6. I'm substituting in my negative 1 there. 2 times negative 1 is negative 2. Negative 2 minus 2 is negative 4. Let me make sure. Negative 4, negative 5, negative 6, negative 2, negative 3, negative 4. Great. Substitute in 0 for x. 2 times 0 is 0. 0 minus 2 is negative 2. Substitute in 1 for x. 2 times 1 is 2 minus 2 is 0. And substitute 2 in for x. 2 times 2 is 4. 4 minus 2 is 2. Now you might notice these are going up by 2 over and over. And that's because each time I'm changing the x, it's 2 for every x. That's why that's working. So let's start putting our points. I got negative 2, 1, 2, 3, 4, 5. Negative 2, negative 6. Negative 1, 1, 2, 3, 4. 0, negative 2. Notice it's not going through the origin. 1, 0, and 2, 2. And remember, these are just the selected answers to this function I'm choosing to make the line. All parts on this line forever all work in the same function. There's infinite answers. Cool. All right, so now we've got that non-proportional. That's our signal. And we also have this fraction, so we might want to mess with our domain. So since I'm messing with thirds, I like to use negative 6, negative 3, 0, 3, and 6. Because finding a third of 6 is easy. It's just 6 divided by 3. And finding a third of 3 is nice. It's just 3 divided by 3. So I'm going to substitute in all my values into my function here at x. So when I put negative 6 in there, a third of negative 6 is negative 2. Negative 2 plus 1 is 1. I substitute in negative 3 there. A third of negative 3 is negative 1. Negative 1 plus 1 is 0. I substitute in 0 for x. A third of 0 is 0. 0 plus 1 is, I did something here. Oh, plus 1 is 1. I did something else here. Negative 2 plus 1 is negative 1. That y value is negative 1. We fixed it. All right, I substitute in 3 for x. A third of 3 is 1. 1 plus 1 is 2. Substitute in 6 for x. A third of 6 is 2. 2 plus 1 is 3. So you'll notice my values are going up. That's because that number is positive. And it's going up 1 whole for every 3 because it's a third. So now I need to plot my points on my graph, my third representation. I have an equation, a t-chart or table, and now I'm going to work on my graph. So negative 6, negative 1, negative 3, 0, 0, 1, 3, 2, and 6, 3. Again, you'll notice not proportional. It doesn't go through the origin, okay? But it is a straight line. And again, this whole line's answers. These are just specific reference points, a domain and a range I chose. And I chose a domain and range that worked kind of nice. So you might notice here, we got some decimal action, okay? So as I'm looking at my decimal, 0.8, it's going to be a little tougher. On this one, I would actually recommend using that standard domain, negative 2, negative 1, 0, 1, 2. I'd also recommend getting out that calculator, all right? You can use the one on your phone even right now, right? Because you're at school at home. So 0.8 times 2. I got a negative 1.6. Remember, I'm slapping x values into here. One cool thing I notice is there's no number here, so I'm going to have a proportional relationship again. Times negative 1 is negative 0.8. Times 0 is 0. Times 1 is 0.8. And times 2 is 1.6. So remember, I'm slapping all my x values here in for x into the function, and it's pumping out that y. Now I just need to graph my ordered pairs, and you just need to get close. Okay, so negative 2, negative 1.6 is like negative 1 2/3 of the way. Negative 1, 0, 0, 1 most of the way. 2, a little more than 1.5. So it's not going to be perfect. It's not going to be pretty. Desmos is going to help you out, though, to make a nicer graph. And again, those are just reference points. I know I've said it, but it's important to keep in mind. Those are just reference points right there. The whole line is the answer forever. There's infinite answers, which is why we need the whole line, because otherwise you'd be working on this thing forever. You'd still never be done. All right? So I hope everybody, like I said, is being safe, doing well. Feel free to reach out with anything you need. Try your hardest. And I just look forward to next time I see or hear from you. All right? Be good.